Okay, let's look at this. Solving for angles real quick. Let's look at this first one right here. So we have a directional north arrow, north line, and we have two bearings, a northeast bearing and a southeast bearing. What we want to do is compute the angle between the two. I like to say and kind of specify real quick, when you're looking at survey plats, you're looking at deeds, bearings can change as far as what kind of bearing set, what they're determining true north is, where they're starting their bearing system from. Regardless of what bearing system you're in and what the bearings look like, the one thing that's always going to hold true, and what I think the intent of having bearings is to tell you what the angular value is between lines. So for example, if this was like a property corner, we got two property lines, three different surveyors can come out, survey these lines, and come up with slightly different bearings. However, the angle should be pretty darn close to the same, should be repeatable. So starting off with this first one, can you guys see that okay?
The Texas calculators, they can calculate the angles of bearing and azimuth, right?
Sure. I believe the trick to learn is how to take degrees, minutes, seconds, and convert that to decimal degrees, and then convert it decimal degrees back to degrees, minutes, seconds. But yes, those TIs should be able to do that. I've got an HP, so you'll have to Google that or ChatGPT that or something else. Here's the first thing I would like to do, or I do. Again, being a very visual person, I'm going to extend that north-south line. And that just helps me visualize, okay, what information do I know? I have these two bearings. Well, hey, I know bearings come off of the north-south line. That northeast bearing is this angle right here. I know the southeast bearing is this angle right here. I know from north all the way around to south is 180 degrees. So I have a straight line. I have these two portions. The overall, what's this piece here?
So at least the northeast bearing,
Is that angle right there.
yes, so we know that the angle,
The southeast bearing is this piece right here. And we know from this point, a straight line is 180 degrees.
so we've got 180 minus the first angle
Mm-hmm.
and the second angle.
Mm-hmm.
And we will be remain with the real angle.
Correct.
Our angle.
Yeah. You could start off with 180 degrees. You subtract this angle. You subtract this angle and you get that. Or you could add those two bearings together and subtract that from 180 to get that. Or you could convert these to azimuths, which, hey, this one's really easy here. That's northeast bearing, so that's going to be the same azimuth. You could convert this bearing to an azimuth. Then you have this portion. You just subtract your azimuths and you have your interior angle as well. More than one way to skin a cat. No matter how you do it, the cat don't like it, and I do not recommend or suggest or like you if you try to skin cats. Quick disclaimer, I guess, there. So what I would do here, I'm going to go 180. I come up with this interior angle being 91 degrees, 25 minutes, 0 seconds. Do I get an agreement with that? Did I do my math right? Okay, first thing else, or something else I would like for you to do after you do a math problem like this. Now, bear in mind, those first ones we were doing, I was just roughly drawing lines just in the general area. If you're looking at an actual survey plat, these bearings are going to be drawn correctly. So if you are calculating an interior angle between some bearings like this, once you come up with your answer, just take a visual look. Does that look right? Does that look like I'm in the ballpark? You know, if you did some math and came up with 176 degrees or 20 degrees, I hope that would like visually stand out like something doesn't look right here. Maybe I need to check my math. Sound good so far? How about this other one here, man? This looks hard. Hard for a non-surveying commoner, maybe, not us. So again, I just extended that north-south line. What information do I have here? What do I know? I have two bearings. I have a southeast bearing and a southwest bearing. Okay. That's telling me this right here. And this bearing is telling me this right here. Care to take a stab? Walk me through how you're going to solve for this exterior angle? Yeah, Adrian, what you got?
So I added the angles that we have together
Okay.
to get 80, 56, 0, 0. And I'm going to subtract that from 360.
Okay, so you added this bearing
Yes.
with this bearing. So you got this total interior here and then subtracted that summation from 360. That sounds like the easiest way to do it and the same thing I would do myself.
I have my answer if you want.
Oh, lay it on me. What you got?
279 degrees, 4 minutes, and 0 seconds.
279 degrees, 4 minutes, and what'd you say?
0 seconds.
I did not do the math on this, so what if I does everybody else agree? Does everybody work through that? Are we good? All right, I like the thumbs up.
Sorry, can you explain again how did you make the calculation? Which method did you follow? We're talking about
What do you know? What information do you know? So you're curious? Walk
that's
through
what I
that.
mean, I want to know which approach did you follow in calculation. Which one?
You can add these two together and come up with this total here, and then subtract that from 360 degrees. Or you could start with 360 degrees and subtract this and then subtract that. Or you could convert those to bearings, or azimuths, I'm sorry. Subtract those, which would give you this, and then you still have to subtract that from 360 degrees. So the method I followed, add these two, subtract that from 360 to get the whole exterior. And this is what everybody else came up with, 279.04. I like to practice math. I will 36. Hey, I got that too. How about this last one here? Draw my line straight through. I like to look and see that. What do I have? What do I know? This looks really, this like super level hard, right? No, shake your head now. Not bad, not bad.
That's the easy one.
Yeah.
So I would
So,
approach it like first, actually it's summary. 360 minus 0 is 0. 0 minus 0 is 0. 0 plus 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 0 is 0 the northwest 27 plus northeast 90 plus southeast 45.
Run that by me one more time.
So now,
So you, oh, hold on. I think I heard like northeast. So you were,
yeah,
if I was to draw a northeast line through here,
yeah, so basically I will just calculate sum the northwest 27. No, 20 on the other side. The 2713.
this here.
Yeah, plus the 90 of the northeast. Yeah,
Okay.
plus the 45. Plus, sorry, no, not 45. It should be from southeast. Then, okay, plus 90 minus 45. 47.
Okay. So you took this plus 90 to come down to here,
Okay,
and then added another 90 and then subtracted again.
and then
Okay. You can do that. That works.
I know sometimes somebody asks me, what is your year equivalent?
Yeah. Yeah. There's a few ways to do this. Or do you want me to show you a completely crazy different way? This is probably what I would have done when I was out in the field. Mark, you were correct in your description of how you solve for that. As long as we all match and agree with the same numbers. What number did you get for that angle, by the way?
I didn't make the calculation.
Oh, okay.
Split the field.
Yeah, I would have gone like real crazy mode here. What if I would have what if I would have extended this line? This southeast bearing, I turned it into a northwest bearing, and I would have had this. I would have subtracted from these two, get that angle, and then subtract that little difference there from 180 degrees.
Yeah.
I know, wild. Another thing you could do is you could take this bearing, subtract it from 180 degrees, and that's going to have this portion. Then you could add that bearing to get that all the way around. So let's see, if I take that, yeah, that's what I came up with. All right, I got a thumbs up. Makes me happy. Any questions on calculating angles from bearings? I don't know if this is going to be good or bad, but I'm going to break these up into smaller chunk videos here. So we'll